All right, thank you for having us. I just want to make sure that that you're hearing us well because we're using two computers at the same time. Everything okay? Okay. All right. So we'll start this talk with a question. What if learning ordinary differential equation began with moving your body? We usually get two reactions. One is curiosity, and the other one is skepticism. So today, we hope that if you're skeptical, we can move you towards curiosity instead. Um, okay, I can't change my slide. Oh, that's a good start. All right, so today, we are talking a little bit about the backstory of this project. We're gonna present our goals for this project, and we give us our methodology, and then we're going to present some activities with videos that you can see what we do in class. Um, so this project began with what I like to call a lucky encounter. Getting to know Professor Lori Teague. And I have to say that this story is kind of funny because I was facing the prospect of teaching differential equations for decades. And that seemed a little bit boring to me, so I needed a change. And while receiving this email from the college about the possibility of teaching interdisciplinary classes, a student was sitting in my office and I just thought out loud and I said, I've loved to teach math and dance together. And so this student just told me, you know what, professor, I'm taking a dance class right now. And I told her, oh, you have to introduce me to your instructor. Absolutely. And so that's how we met. And we started talking about, face portraits and dynamical systems and all these things. And we came up with our first class that was the sidecar course. And as you can see in this slide, this is a little dance, but this is kind of a story of what we've done. So we've worked on different kinds of projects. This interdisciplinary course, then we turn into a research study for the students. Then we did a freshman seminar where the students were either interested in math, interested in dance, or neither of those. So that was very interesting. And then we participated to a college-wide activity that was the Link project, and we connected between two advanced course, both in dance and in math, that is partial differential equations and dance literacy. But what we're really talking about today is our lab for differential equations. That's called differential equation through movement. So this lab got approved last year from the curriculum committee and is supposed to run every spring. And it's just an hour added to the differential equation course, and it's optional for students that are taking or have taken differential equations. Um, we switched from Math Through Movement to Math Leap. And our slogan is, are you ready to take the math leap? And this project has three main goals. One is to deepening the understanding of people who already like and enjoy math, or trying to get the attention of people that are not really inclined to math or to the sciences, and try to get people together from different backgrounds. Um, our theoretical framework is grounded on embodied cognition. What we try to do is to get rid of the math anxiety. We try to engage the students. And the tools that we use to do that are really related to the space that we use. Unlike in math classes, we use the open space of a dance studio. So we don't have like people sitting in desks. We lose that structure there, and also the feedback is very different because we don't really have graded assignment in the a standard way, but we do offer feedback every day in a very direct way. And the relationship between instructors and students is very different when we come to a dance studio. Of course, we're not the only ones doing like merging math and dance. But we think that our approach is quite unique in the sense that we are actually helping one specific class, and especially with the modeling part that is usually very difficult for the students, doing activities with our body.
This slide, hey everybody, I've been kind of loosely watching the other presentations, and as much as I have learned in collaborating with Manuela, this has been fascinating to me because it's been a long time since I took math. Um, so this is a big leap for me. This slide is really our pedagogical tools, and we're going to move through these kind of quickly because we want to get to really showing you some video. Um, Footage of what some of these things really are, but they're all important in the class. Icebreakers, maybe you do them yourself in your classrooms. They really are deconstructing kind of that tension or that hierarchy that sometimes exists um, naturally between professors and students. They're often games. One of our first ones, which is trying to learn their names, is just creating a personal movement that imitates or expresses something about you as a person. And this helps them start to get to know each other. Our warm up today, in fact, we had our lab and I focused on mindfulness so that they become better listeners in class. How do they listen through their body? And so they were back to back on the sitting on the floor, breathing. And so we choose often very simple things for them to invest in and sense body, energy, space, and time. Those then lead into warm-ups, movement material that is often directly related to the mathematic concept that we are focused on that day. Um, the way that we approach how they learn is to try to create an environment where they want to ask questions. This is still typical to a classroom setting. We will ask a question and they just stand there and look at us at first. And then we try to get them laughing or posing ideas or get someone to talk. And then usually that has sort of some momentum in terms of how they begin to um, mainly it happens over time in the semester because as they get to know each other, they talk a little bit more. But we don't give answers. We really facilitate uh, structures for them to creatively problem solve. That's something we do. That is sort of the nature of it every time. The other thing that's important is reflection. So after these labs, they have a short reflection assignment. Sometimes we ask at the end of the class, what's the takeaway? What's your popcorn today takeaway? But they write, about a paragraph or two about what they really felt in terms of their own personal choices in these improvisations. Yeah, it's a lot of games because again, we're trying to make the class fun. Theatrical role playing, movement improvisations that have prompts. As we are trying to do with you today, we're really just trying to spark curiosity and allow them to begin to trust their intuition because Manuela definitely recognized that students were computing and memorizing, and we're trying to get them out of that. Collaboration was something we worked on today too. So everything we did was in pairs today. Sometimes it's larger groups. So they begin because there is always a variation of a student that knows more or knows the content differently. How do we get them to feel comfortable asking a question and collaborating with someone that may have a different strength than them? Certainly in movement, we say this all the time, mistakes are essential. So playing with that in an improvisation, everything you do is right because it's your choice. When we get into whether that really can be applied to the mathematical model, there are probably some rights and wrongs or things that express it more clearly. But feedback is a real tool for their growth. So this past week, or in their first reflection assignment, I really was very conscious of affirming whatever they said to begin to build that confidence. The unpacking the personal choices for me is probably one of the most important things. And uh, I guess the way that I ask the question often is, what did you notice in the improv? So that feels kind of macro. They'll just say, I did this, or, my arm did that, and then, so what is that? So how do we unpack what it literally means or what it represents in the mathematical model? Um, yeah.
All right, so we're gonna show you hopefully four activities today that we worked on. Those videos are from last year, so our first run of this lab. So as you can see, those are topics that come from the entire course, right? We cover first order, second order linear systems of ODEs. And I just want to say that here at Emory, the students don't have linear algebra as a prerequisite to differential equations. So those activities on linear systems are always with activities that come from linear algebra, just so they can practice that as well. Um, so here is a very dense slide with all the objectives and topics from both sides of our worlds. But so basically here we were trying just to introduce the study of autonomous equations through population dynamics before they would see that in class. And so we wanted them to kind of get acquainted with growth, with lack of resources, and trying to understand what the asymptotic behavior of a differential equation would be. And so we're gonna show you like different stages in the labs. This is the warm up, and I'll let you watch the video without talking. Wake up your body. I always think like it's shaking out a little down comforter, waking up all the molecules in your body. And you can be passive in your weight of not bouncing that much and feeling it down. That helps you get grounded. Or you can resist gravity a little bit. And on this, you're going to place your center of gravity over the ball center of gravity. So we're going to shift out. Kind of like a plank, you don't have to hang on to that. And then you're going to push back like this. And you roll up, then you roll down. Then you roll down. Yeah. And you're getting energy that goes to the top of your head, and you're taking energy back to your head. Wow. It's not up, take the ball. And what I want you to do is just play a little bit, take moving and take ball again. Direction. I'll turn back. I think I've hit the center of gravity, so you can connect to the center of gravity. I'm going to get arms. And I'll turn back. Warming up our arms a little bit, just play different ways to play the center. So the second video is about learning a phrase. The students don't have any dance prerequisite, so we're not assuming that they know anything about dance or movement studies or anything like that. And so Lori teaches everything that we need to know to do those activities. 1, 2, 4, 1. Add the R. 1, 4, 1. But I do try to build on pedestrian movement, or it's either their movement. 1, 2, 3, 4. 1, 2. What is a movement vocabulary that everybody can do? Okay, let's do the music. So and so this first activity was about accumulation of people to simulate growth. Give me word in the sea. I'll turn right back around. I don't want to and then we introduced physio balls to kind of consider other factors in the population. And the prompt was for the students who had the physio ball to keep moving the way they did
Can
before,
convince parents.
and for people without the physio ball to kind of adapt to the other ones.
Okay, so this gives us an example of some of the ways that they articulate their personal experiences. We've highlighted a couple things because we know this is a lot to read at once. But the second one in particular, I think, that what they choose affects other behavior. And so that's sort of a broad way to look at systems of behavior in a human body or in human choice, and then how those systems of behavior are paralleled to maybe a mathematical model. It takes time, but they start to find those parallels through we see that through their reflections. Just this week, again, a student wrote about the mind-body connection, and that he was paying attention to it more outside of class. So that's always a win-win, in my opinion. You want to go to the
Yeah, I don't. So the second part is about second order differential equations, and we were trying to get the students comfortable with oscillations and vibrations. So we introduced free vibrations, damped vibrations, and forced vibrations, and resonance as well. And we did a lot of partnering here. As you can see, the warm-up was really bouncy.
Yeah, I'm trying to also help them feel each body part in as passive weight, and then to understand how they can activate different qualities of weight, as we did.
Just a heads up, there's only about 2 minutes left in the talk portion.
Maybe we should go to the other one. All right, so this is another example for second order differential equations, and we use the technique of canon. Maybe
everything that's always in the right corner is the movement concept. So canon is, like in music, is an echoing of it's really a choreographic tool. So that's always the movement parallel. We found this one quite beautiful, and this took a while, though, to teach several classes for them to understand what to do. In this video, they got into groups, and after learning that as a whole class, they had to come up with their own ideas, and they had to create their own materials in a full count game. That became for you.
so just to conclude, I'm gonna skip this. We would like to extend this project to other classes, either more advanced, like partial differential equations, or more basic, like calculus and linear algebra. We've seen some of the topics already in the directed studies, and they seem to work pretty well. Especially with retaining the materials, which I think is one of the biggest concern right now, that they memorize and that they don't retain the material. And it would be great to also have like some kind of workshops in which we can train other instructors to do the same if it turns out to be helpful.
And I think we have felt very supported here, as referencing the slides earlier, of the initiatives that Emory has given us to step in and begin collaborating in different disciplines. We have a Center for Teaching and Excellence that does workshops where professors would choose to come and expose themselves to something like this. And also in other departments, there was a conference several years ago by the anthropology department on embodied learning. So these topics are probably in your world as well, a way to leap in to this with these umbrella headings. I guess we'd love to open it up for your curiosity questions, or
skeptical ones.
For your skeptical questions, yeah, or comments, or yeah.
I have a question. You've run a few different iterations of this course before settling on the lab that accompanies a math class. Did you always have mathematical prerequisites or dance prerequisites for the students who are taking these courses?
No. So for instance, for the freshman seminar, there was no prerequisite at all. They were just like freshmen coming in. And again, some of them would know that they wanted to step into math, but some of them had actually no clue what to do. And so since we did kind of interviews like afterwards, that actually told us that, they came in hating math. It's pretty strong, but that's what they said. And so they said, well, actually math it is accessible. So that for us was a great achievement.
I think for me, this is not directly answering your question, but what is this whole project has given me is this looking at how we label ourselves, and the stereotypes around dancers and math students. And it really just breaks it all apart, because there's just hyper creative people and beautiful movers in both areas, and amazing thinkers in both areas. And I just love the crossover, and maybe that's why I still feel so invested in this project.